The universe is vast, mysterious, and often stranger than fiction. We've explored galaxies, black holes, time illusions, and even simulated realities. But what if the cosmos itself carries scars? Remnants of creation, stretching across space, thinner than atoms, but heavier than mountains. These aren't mythological ideas. They're theoretical objects in high-energy physics called cosmic strings. These ultra-thin, ultra-dense filaments might be the very cracks in space-time, left over from the Big Bang. And if they exist, they could hold the key to understanding the birth of the universe, gravitational waves, and even the structure of reality itself. Let's unravel this idea. What are cosmic strings? Cosmic strings are not strings like spaghetti or shoelaces. They're one-dimensional topological defects, theoretical structures predicted by certain grand unified theories of particle physics. Think of them as hairline fractures in the fabric of the universe, formed as the universe cooled and expanded in its earliest moments, much like cracks forming in ice as water freezes. These defects would be infinitely long, or looped into massive closed rings. But here's the kicker. They'd be thinner than a proton, yet contain more mass per centimeter than Mount Everest. Their gravitational pull would be so intense they could warp space-time and act like cosmic lasers, bending light and slicing through matter. Birth of strings, a frozen relic. To understand where they come from, imagine the universe in its first trillionths of a second. It was unimaginably hot, dense, and chaotic. As it expanded, it underwent phase transitions, much like how water turns to ice or steam condenses into water. During these transitions, the fundamental forces, gravity, electromagnetism, the strong and weak nuclear forces, separated. But this process wasn't smooth. In some regions, mismatches in symmetry occurred, creating defects in the field. These defects could stretch across the cosmos, forming cosmic strings. They're not made of atoms or particles, but of raw energy, frozen in a stable configuration. Once formed, they would last for billions of years, perhaps until today. How would we detect a cosmic string? Detecting a cosmic string would be like finding a thread thinner than a proton, stretching across galaxies. Fortunately, they leave behind unique signatures. 1. Gravitational lensing. Cosmic strings bend light in a very specific way. If light from a distant galaxy passes near a string, it would be split, creating two identical images side by side, like a mirror. This lensing would be unlike anything seen from galaxies or black holes. 2. Gravitational waves. Cosmic strings can form loops, which oscillate and decay by emitting gravitational waves, ripples in the fabric of space-time. These waves would have a distinctive frequency, different from those created by black hole mergers. Detectors like LIGO, Virgo, and future instruments like LISA might one day pick them up. 3. Pulsar timing arrays. Millisecond pulsars, rotating neutron stars, emit regular radio pulses. If a cosmic string passed near Earth, the timing of these pulses would shift, revealing its presence. Projects like Nanograv are already studying such data and have recently found signals that could be consistent with cosmic string activity. Why cosmic strings matter? You might be wondering, why care about some invisible line in space? Because cosmic strings are a direct window into the first moments of the universe. They're a relic of symmetry breaking, a moment when the universe chose its fundamental laws. Studying them could confirm or rule out entire branches of particle physics, including grand unified theories and superstring theory. And here's where it gets cosmic. Some theorists believe that superstrings, the building blocks of the multiverse, in string theory, could manifest as cosmic strings in our 3D universe. In that sense, cosmic strings might not just be leftovers. They could be signposts from higher dimensions. Could we interact with one? Let's say we found one. Could we study it? Touch it? Probably not. At least not safely. A cosmic string's gravitational energy would be so immense that passing near it could sever atoms, tear apart planets, or disrupt time itself. But theoretically, a stable loop of cosmic string could become a gravitational wave antenna, or even a form of propulsion. Some science fiction writers have imagined wrapping a spacecraft around a cosmic loop to generate near-light-speed travel. Others suggest strings could stabilize traversable wormholes or generate closed time-like curves, allowing time travel. Though purely speculative, the implications are tantalizing. What if they don't exist? It's important to remember, we haven't observed a cosmic string yet. Many surveys have searched the sky for the telltale signs. Double images, gravitational lensing arcs, and unusual background radiation distortions. So far, nothing conclusive, but the absence of evidence is not evidence of absence. Cosmic strings may be rare, or they may exist on scales or energies just beyond our current reach. With more sensitive telescopes and gravitational wave detectors coming online in the next decade, we may finally glimpse one, and with it, a thread back to the beginning of time. Final thought. The universe may be a finely woven tapestry. Galaxies, stars, planets, all hanging delicately on threads we cannot see. Cosmic strings are more than a theoretical curiosity. They are a bold reminder that the universe carries history in its very fabric. They whisper of a time when everything was energy, when reality crystallized into the world we know, and perhaps of worlds we don't yet understand. Here on Infinity Beyond, we follow those whispers, all the way to the edge of physics. Because sometimes, it's in the smallest threads that the biggest truths are hidden.